Hi, welcome everyone. In this video, I'm going to show you how to estimate simple panel data models like fixed effect and random effect models with robust standard errors so that you can make it robust for specifications like cross-section dependence, autocorrelation, heteroskedasticity, and other issues. So we'll start with one example. So the initial commands will load the data file, okay, and then it will convert the data file into a panel data form. For that, you have to have the cross-section identifier and the here variable in your dataset. And then you can list down the variables using this command. It will show you the variable names. In my example, there were many rows, but only few had variable names. And then you can also check if these variables are numeric or string. So you can have a look for each variable. For example, my first variable is asset. So I will come and have a look at the asset variable. So it is somewhere at the end. So I noted that this variable is shown as character. So I have to convert it into a numeric, and I also convert it into log form. Similarly, there was an ESG variable. If I look at the ESG variable in this report, it is also showing a character. So I have to convert it into numerical form. Then there was a age variable. So if I look at the age, it is already numeric. So I don't have to convert it into numeric form. So I will convert them into relevant forms. So it says the NA introduced by Coercion. So what it does mean that if there are any alphabetic letters like NA or not available or any form, it will remove it and make the cells empty and only keep the numerical values. Okay, and then when I run this command, this is a simple pooled regression formula. You can convert it into any other form. So for that, if you search PLM, you can convert it into from the model. You can convert it within random HT between pooling. Okay, so there are an FT. So if I select within, so it will become fixed effect, and if I select random, it will become random effect. So we'll start with pooling, and if I and then we will first estimate this model, and you can have a look at its results. So if I make it move it up, you can see that it is pooled regression, and it has around 10,000 observations, and these are two variables, and both of them are significant. R square is something around 33%, F stat is significant. Okay, so this is standard result. And now we have already in previous videos discussed how to check for diagnostics in the model, and assuming that there are problems in the model, first of all you convert this model into fixed effect. So I will write within. So when I run within, so you will see a fixed effect model. So it will say within effects one way within effects model. So these are its results. So now the intercept is not there because for each cross section the intercept is calculated and it is stored different separately. You have to request the model to show it. Okay, now what we'll do is we'll go for discussing the variance covariance matrix. So first of all, we'll start with VCOV SCC. VCOV SCC. So if you look at this, this is Driscoll and Cray 1998 robust covariance estimator. This is actually for cross-sectional and serial autocorrelation. So this model can help you to solve the cross-section dependence and time series autocorrelation. So if there are both of the models there, both of the problems are there. If you use this matrix, it will make your model robust to these two problems. So these are its results. So you can see this is fixed effect model with Driscoll and Cray estimator. And then we have BK. If you look at this, this is Beck and Katz variance matrix, which is also known as panel corrected standard errors, which is usually used for panel data. Whenever you make a panel data, it says that it can adjust for panel data. So if you want to understand what does it say, so you can study it's the discussions. So and I run the PCSC, and then if I show it this command, it will show its results. Okay, then there is VCOV HC. HC is you have to go here. So it's a heteroskedasticity consistent covariance estimate. So this, if you use this, it will be consistent to heteroskedasticity if there is in the model. So we can show it using this. Okay, and there is now last one is NW. This is Newry and West 1987 estimator. This is for serial autocorrelation. Okay, not for the cross-sectional autocorrelation. So when you run this, you will have it will take some time to estimate. So when the sign is over, it means it has estimated it. Now if we run this command, it will show you the estimates for which is consistent for serial autocorrelation. So this way you can estimate simple panel data models, which is also known as static panel data models, to control for these common issues. Now, other thing is that if you want to make sure that it is also both are heteroskedasticity and cross-check independence and autocorrelation, then you should go for FGLS model, which has the ability to handle both. So if you go towards FGLS, so it will show you this PGGLS model. So if you use this model, let's say if I copy this and convert it into PGLS model, rather than PLM, I will use PGGLS. And then if I look at the example of commands, so variable names are there and then it is within. So if I run this model FGLS, and then if I run this command, okay, and then model FGLS, if I show this is simple FGLS model and the coefficients are there, then I need to make sure that it's summary, so that it gives me more details rather than only showing the coefficients. So this is the FGLS model. Now you can go within the FGLS model to make it robust. So and the other robustness method, if you want to understand, so you need to open the library for summary and understand what features you can add in the summary, so that you can make it more robust. So in this video, we discussed how to make your model robust to standard issues, and then use the FGLS model, which can be made robust to multiple issues. So there are videos available in the channel where FGLS model has been discussed. If you have any queries, you can send us a comment and I will try to sort it out in coming videos. Thank you.